Okay, let's look at number 1. We have to solve the system of equations by graphing. So we have two equations here. The first one is already in slope-intercept form, so let's go ahead and graph that equation first. So let's just make some notes about the equation. We have y equals 3/2 x minus 4. So the slope is 3/2, and the b value is -4. So that means we are going to place our y-intercept at the point 0, -4. And then from there we are going to count up 3 units and 2 units to the right. So let's start at 0, -4. And now we're going to count up 3, 2 to the right. And we can also go down 3 and 2 to the left to get points on both sides of the y-axis. Okay, let's connect our dots with a nice straight line. Alright, now let's look at the second equation. So this was the 2x minus y equals 6. So our goal is to isolate y. So the first thing we're going to do is subtract 2x from both sides. So that's going to give us negative y equals negative 2x plus 6. Now we're going to divide both sides by -1. So we will get y equals positive 2x minus 6. So here our slope is 2 over 1, and our b value is -6. So again, that means we're going to start at the point 0, -6, and from there we are going to go up 2 units and 1 unit to the right. So starting at 0, -6, there we are. And now I'm going to go up 2 units and 1 to the right. Up 2 over 1, up 2 over 1. And I'm going to keep doing this until I land on a point that is also a point of the other line. Up 2 over 1, there it is. Up 2 over 1. Alright, so that point right there is the point that is on both of those lines. So now I use green for this color. So now I am going to draw a line through all the green dots. And right here is my solution. Now I still need to make sure that I write the ordered pair of the solution. So we are 4 units to the right of the origin and 2 units up. So our solution is the ordered pair 4, 2. Make sure that you include that as part of your answer, because your answer isn't just the graph. Your answer is the ordered pair, which is the solution. Alright, let's look at number 2. So we can solve the system using substitution or elimination. So when I look at this, I notice that I can eliminate the x's. If I multiply the first equation by 2 and the second equation by 3, I'm going to get 6x minus 24y equals 12. So again, make sure you're multiplying both sides of the equal sign. And this becomes negative 6x plus 24y equals negative 12. So again, when you distribute, you're distributing it to every single term on both sides of the equation. Alright, now I'm ready to add straight down. Well, on the right side, 12 plus negative 12 is 0. On the left side, negative 24y plus 24y is 0y, and 6x plus negative 6x is 0x. So I wind up with an identity statement. It tells me that 0 equals 0. Since this is a true statement, What it means is that I have a dependent system. This system is called dependent, which means there's an infinite amount of solutions, because really what I have here are two of the same equations. If I were to graph each of these, one line would graph right on top of the other. It would be the same line. So what that means is that there is an infinite amount of solutions. And we're going to use the notation that we learned about in the notes. There's two ways we can write it. So if we want to think about writing an ordered pair, kind of like we did up here, we can't just pinpoint one ordered pair, because like we said, there's an infinite amount of solutions. So for whatever value you plug in for x, if that value, you take that value of x and then plug it into the equation written in slope-intercept form, which would be 1/4 x minus 1/2. So no matter what value you plug in for x, when you substitute that into the slope-intercept form, you get the y value. So if you're wondering where I got this from, it was because I chose one of these two equations and rewrote it. So let's kind of do that off to the side here. You can choose either equation, because remember we said they're the same exact equation. So let's choose this one. So to solve for y, I'm going to add 2x to both sides. That's going to give me 8y equals 2x minus 4. And I'm going to divide everything by 8. So there's my 1/4 x, and there's where my 1/2 came from. So for every value of x that I choose, I can pick any value for x, and I'm going to plug it in here. And when I evaluate the right side of the equation with my given value of x, I get a y value, which would be the y value as the other part of my ordered pair. You can also write it in set builder notation. So this is saying the solution set contains the set of all points x comma y such that y equals 1/4 x minus 1/2. 1/4. Such that y equals 1/4 x minus 1/2. Or right here, instead of the slope-intercept form, I could have just picked one of those two and put them in there. Either one. Okay. Let's look at number 3. So this says, starting at the same point, Angie and Peyton jog in opposite directions. Angie can jog 2.5 miles per hour faster than Peyton, and after 1.5 hours they are 16 miles apart. How fast can each person jog? So I always recommend drawing yourself just a picture to kind of understand what's going on. So it says they start at the same point. Let's say Angie is going to the right or east, and we'll say Peyton is going left or to the west. So they jog in opposite directions. Angie can jog 2.5 miles per hour faster than Peyton. Okay, so let's we're going to let Angie's rate equal r, and Peyton's rate, now let's think about this. If Angie is 2.5 miles per hour faster than Peyton, we can write Peyton's rate as r minus 2.5, because Angie is faster, so that means Peyton is slower. Or you can also translate it in a different way. We can let Peyton's rate be plain r, and then Angie's rate would be r plus the 2.5. And that kind of does the literal translation, where Angie can jog 2.5 miles per hour faster. So you take Peyton's rate and add 2.5 onto that, and then that would be Angie's rate. Alright, let's write down some other things that we know. We know that after 1.5 hours, they're 16 miles apart. So they both ran for 1.5 hours. Okay, their times are exactly the same. So if you can kind of notice what I'm doing here, I'm doing the distance, the rate, and the time for each girl. So this is Angie, and this is Peyton. And we know that after 15 hours, they're 16 miles apart. So what I don't know is how far each one of them traveled. But I do know that together, it adds up to 16. So if I have Peyton's distance, we'll call that distance 1, plus Angie's distance, we'll call her distance 2, I know that it equals 16 because they're 16 miles apart. So for instance, let's say Angie jogged 10 miles this way, and if Peyton jogged 6 miles that way, their total distance apart would be 16. Or if Angie jogged 12 miles and Peyton jogged 4 the opposite direction, they would be 16 miles apart. So I kind of have a little equation set up here. Distance 1 plus distance 2 would equal 16. Now, we know our formula, distance equals rate times time. So what we're going to do is we're going to write a distance formula for Peyton, and we're going to write a distance formula for Angie. I'm going to keep it in my little chart like I had before. So Peyton's distance, we'll call her distance 1, is the rate times time. Well, her rate is r, and her time is 1.5. Angie's distance, we'll call her distance 2. Now her rate, we're going to use the r plus 2.5 times the time, which is also 1.5. So here's the rate times the time, and again the rate times the time. And then let's go back over here. We know that the first distance plus the second distance equals 16. So I'm going to take this plus this and set it equal to 16, except I'm going to use these expressions and add them together. So distance 1 plus distance 2 equals 16. So her distance 1 is going to be r times 1.5, which is 1.5r, plus distance 2, which is 1.5 times the quantity, r plus 2.5, and that equals out to be 16. Now I'm going to distribute, it should be 1.5r plus. 1.5r plus, now I'm going to distribute that 1.5, and then so it's going to distribute here, and then times the 2.5, going to give me 3.75 equals 16. Combine like terms. So 3r plus 3.75 equals 16. You're going to subtract 3.75 from both sides. So 3r is 12.25. Now, when you divide that out, you're going to get a decimal on your calculator, because 3 does not divide evenly into 12.25. So when we divide that by 3, this is about 4.083, because it's repeating. So we'll say it's approximately 4.083. That's miles per hour. Now, if we convert that to a mixed number, so we get an exact answer, the 4.083 is actually 4 1/12 miles per hour. So this was R, so this was Peyton. So Peyton's rate is 4 1/12 miles per hour. And so now what we have to do is we have to find Angie's. So remember, Angie was 2.5 miles per hour faster. Okay, so I am going to continue this on the other side. So far we know that Peyton's rate, she is 4 1/12 miles per hour. And we know that Angie was 2.5 miles per hour faster than her. So we have to do 4 and 1/12 plus 2.5. So we want a common denominator. So this will be 4 and a 12 plus 2 and 6/12. Sorry, I shouldn't have a multiplication there. I should have a plus sign there. And this becomes 6 and 7/12. Or, if you turn that into a decimal, it's about 6.583 miles per hour. So here's Peyton, and there is Angie's speed. So how fast can each person jog? So Peyton is 4 and 1/12 miles per hour, and Angie is 6 and 7/12 miles per hour. Now, you'll notice I really didn't use a system of equations here. So what I'm going to do is I'm going to put a pen cast up to show how you would use a system of equations, and then you can decide which one you like better. Some people like to do it all in terms of one variable. Some people like the two variables with the system. So we'll go ahead and we'll look at that on a pen cast, so I will post that as well. Alright, let's look at the last one, number 4. Alright, I'm actually going to do this second one. I'm going to do this one first because that one's pretty easy to graph. So it's just x is less than 3. So remember, think of it as if it were x equals 3. If that were x equals 3, that would be a vertical line crossing 3 on the x-axis, except the fact that it's less than tells me to make a dashed line. Okay, and it's less than 3, so it's everything to the left. So I'm shading everything to the left of this vertical line that I drew. Alright, now let's look at this other equation, or I'm sorry, this other inequality. So we have x minus 3y is less than or equal to 6. Let's subtract x from both sides. So that gives us negative 3y is less than or equal to negative x plus 6. And we are going to divide everything by negative 3. And when I do that, what did I forget to do? When I do that, I have to flip my symbol. So this becomes y is greater than or equal to 1/3 x minus 2. Okay, because I divided by a negative 3, I had to flip my symbol. Alright, so we're just going to treat that as y equals 1/3 x minus 2. So minus 2 means my y-intercept is at negative 2. And 1/3 x means I go up 1 over 3. Now, since this is an inequality, I'm not really concerned with that one particular point where they intersect, like I was with the first one, which was a system of equations. I'm concerned with the whole area, not just one particular point. So I'm going to graph this line. It's going to be a solid line because it's a greater than or equal to. Okay. And I can do a test point. So let's test 0, 0. So x minus 3y less than or equal to 6. Well, if I plug 0 in for x and 0 in for y, I'm just getting 0 is less than or equal to 6. Yes, that's true. So that means 0, 0 is a solution. So I shade towards 0, 0, which means I shade the half plane that contains the point 0, 0. So then we can see here are the boundaries for my solution area. Right there. And then the double shading, here's where the shading would overlap. So there is my solution set.